All right, number 5. We have the fourth root of 3h plus 5 equals the fourth root of 5h minus 7. So both sides have a fourth root and they're isolated, they're by themselves. So we're going to raise both sides to the fourth power, and that will cancel out the fourth root, leaving us with just a simple linear expression. We will combine the variable terms. I'm going to subtract 3h. Since I'm moving the 3h over, I'm going to move this 7. So the h's are on one side and the numbers on the other. Those will zero out. 5 plus 7 is 12. 5 minus 3, 2h. Divide by 2. And we get 6 is equal to h. Of course, you want to plug this in and check and verify. You plug in the 6. 3 times 6 is 18. 18 plus 5 is 23. And then over here, if we do 6 times 5, we get 30. 30 minus 7 is 23. So both of those expressions are equal. So we would say 6 is our solution. Our solution set is 6. All right, so this one is going to be a little bit more lengthy because we have two radical terms. Now, the shortcut to solving these would be to isolate one of the radical terms and then square both sides, and you'll end up having to square the problem twice, but there's going to be a lot more work if you leave them on the same side. So we have a plus 13 minus square root of a equals negative 1. Okay, so I'm going to isolate this radical. I'm going to move this one over. I'm going to add that to the other side. We're adding that, so it's going to be equal square root of a minus 1. Now that I have one of them isolated, we're going to square. Square root goes away. Now on this side we have a binomial, so we have to do that little square double square formula. So I'm square the a squared, that gets rid of the square root, gives me a. Negative 1 times this will give me a negative 1 square root of a, but you double it, so we have a minus 2 square root of a. And then you square negative 1, gives you a positive 1. Now when you get through that part, we're going to isolate this radical now. So I'm going to move the a term over, move the constant over, and then once I have this square root isolated, I'm going to square again. I'm going to subtract a. I'm going to subtract 1. Okay. So the a minus a zeroes out on both sides. It's the same. Positive 1, negative 1 zeroes out. 13 minus 1, 12 equals negative 2 square roots of a. Since 12 is divisible by 2, I'll go ahead and divide the negative 2 off. And that's going to leave me with negative 6 equals square root of a. And then now this square root is isolated, we're going to square both sides. And negative 6 squared will give me a 36. And square root of a is just equal to a. So it looks like our solution set is just the square root of 36. Of course, if you go back and plug it in and check, this will give you the square root of 39 minus the square root of 36 equals a negative 1. Now this seems like it may not work because you're taking the square root, and usually square root is looking at positive. and this is being equal to a negative. So let's actually look at this to make sure. 36 plus 13 minus the square root of 36 equals negative 1. That is the square root of 39 minus 6 equals negative 1. Square root of 39 doesn't look like it's going to give me anything whole. No, I'm doing 39, it should be 49, I can't do math. 49. This will give me 7 minus 6, and that's going to give me a positive 1. Okay, sorry. I don't know why I'm saying 39. I'm just adding 3. 49, square root of 49 is 7. 7 minus 6 is a positive 1. They're saying negative 1, so this 36 doesn't work. So we have no solution. So you do this little empty set, and that's how you say no solution.